So let us talk about database management system today. In short, we call it as DBMS, database management system, or DBMS is simply a database system which consists of collection of interrelated data. This data has to be interrelated. This is very important. These are the set of programs to access the data. So a set of application program to use to access, to update and manage the data is database management system. And DBMS contains information about a particular enterprise, organization, institute. DBMS provides an environment that is both convenient and efficient to use. Let us see the history. Early 1960s, first general purpose database by Charles from GE. He used the network data model. Then in late 1960s, IBM developed information management system, IMS. This is used to, using hierarchical data model and led to SABRE, the airline reservation system developed by AA and IBM. Still in use today, this is a huge achievement. The 1970s, Edgar Code of IBM developed the relational data model. Now this changed the whole course of database management system which we know today. So led to several database management system based on relational model as well as important theoretical results. Code won Turing Award, most prestigious award. And 1980s, relational model dominant SQL standard came into picture. And late 1980s, 1990s, DBMS vendor extend system, allowing more complex data types like images and text as well. And we're going to see most of them today. So what is the purpose of DBMS? To see the data redundancy or inconsistency. So some information may be duplicated in several places and all copies may not be updated properly. These two things, which we call as data redundancy and inconsistency, is not there in DBMS. Also, difficulty in new program to carry out each new task is again what the purpose of DBMS is. And data isolation means data in different formats, difficult to write new application programs, different files and formats. All these our DBMS takes care of. Also, the security issues, the integrity problem. Every user of the system should be able to access only the data they are permitted to see, not others. For example, payroll people only handle employee records, cannot see customer accounts. Tellers only access account data and cannot see payroll data. So difficult to enforce this with application programs or normal legacy programs. That is why we have DBMS. Again, the integrity problem. This integrity data may be required to satisfy certain constraints. For example, the lowest balance can be, say some amount. So again, if it's difficult to enforce or to change constraints with the file processing approach. So file system could not do it, but our DBMS does it. What are the basic DBMS types? Linear files. You have a sequence of record with fixed format, usually stored in a single file. So this was the basic type, and others, the problems of these linear files were changed in other upcoming DBMS. So let us see linear files. It has a limitation like single file. Example query is like salesperson is equal to some name and price greater than 100. So only one single file. While hierarchical data, it follows some hierarchy. So there are trees of records, one-to-many relationship. One-to-many relationship. Limitations where it requires duplicating records, means man-to-many relationship. The problems, when updated or when updation is done, some problems were there, and retrieval requests knowing the structure, like traversing the tree from top to bottom using a procedural language. So these were some problems. And then network structure. This was similar to hierarchical database, with implementation of many-to-many relationship. So many-to-many relationship came into picture, then relational structure, and then came object-oriented structure. Means you have objects, means collection of data items and procedures and interactions between them. So is this really a new paradigm or a special case of network structure? separate implementation, this implementation versus implementation on top of RDBMS. So all along you are going to listen to this word RDBMS, Relational Database Management System. So let us start with the data models. First of all, I mentioned hierarchical model. You can see this is how hierarchical model looks like. The hierarchical model data model organizes data in a tree structure. This is a tree structure, and there is a hierarchy of parent. You have a parent, you have a child, and this structure implies that a record can have repeating information generally in the child segment. So hierarchical DBMS were popular in late 1960s, but with the introduction of IBM's IMS DTMS through the 1970s. Then came the network model. This is the network model. Not you can verify it's somewhat like tree model also, but the popularity of network model coincided with the popularity of hierarchical data model. So some data were more naturally modeled with more than one parent per child. So the problem of the previous model was taken care here. So the network model permitted the modeling of many-to-many relationship in data. Many-to-many was not available in the previous one. So in 1971, the Conference of Database System Languages, also known as CODA-CEL, formally defined the network model. Then came the relational model. This is RDBMS, Relational Database Management System, a database based on the relational model developed by E.F. Code, again the person who won the Turing record. So relational database allows the definition of data structures, storage and retrieval operations, and integrity constraint. So in such a database, the data and relation between them are organized in the form of tables. How simple it looks, how simple it is, but this simple thing won this man a Turing award. So a table is a collection of records, and each record in a table contains the same fields. So what are the properties of these relational tables? The values you will find in relational tables are atomic. Each row is unique. Column values are of the same kind. The sequence of columns is insignificant. The sequence of rows are insignificant, and each column has a unique name, right? So then object-oriented model, object DBMS add database functionality to object programming languages. So they bring much more than persistent storage of programming language objects. So a major benefit of this approach is the unification of the application and the database development into seamless data model and language environment. So object-oriented languages came, so our RDBMS, or the database management system, shifted to absorb them, and that is how object-oriented model evolved. Then came semi-structured model. So in a semi-structured or data model, the information that is normally associated with a schema is contained within the data, which is sometimes called self-describing. So in such database, there is no clear separation between the data and the schema, and the degree to which it is structured depends on the application. Schema actually is the overall design of the database management system. This is the architecture of DBMS. This is the external view for the user. These are the end users. You have an external view. Let's go inside. This is the conceptual level. You have a conceptual level. So there is some external conceptual mapping. Then let us go down, and we have an internal schema, and we have a stored database here. Again, some conceptual internal mapping. So we have external level, conceptual level, and internal level. These are the three levels in the architecture of a database management system. So what is the external level, or levels or layers? External level is described by schema, that is, it consists of definition of logical records and relationship in the external view. Then we have conceptual level. In this conceptual level, this represents the entire database. Conceptual schema describes the records and relationship included in the conceptual view. And in this internal level, the last level, the lowest level, The internal levels indicate how the data will be stored and describe the data structure and access method to be used by the database. That is why this is not available to the general users. What are the components of database management system? Right now you might be thinking they are tables or files in the form of tables somewhere. No, actually, database management system involves or has everything. You have hardware. It can range from PC to network computers, software like Dbms, operating system, network software if necessary, and also the application program. Then comes the data. This is used by the organization, and description of this data is called the schema. And then people, of course, you and me. It includes database designers, DBAs, application programmers, and end users. Then comes the procedure, the instructions and rules that should be applied to the design and use of database and DBMS. So do we have some languages also in DBMS? Yes, we do have. We have data definition language. Data definition language, DDL in short, are statements used to define the database structure or schema. So if you want to define a structure, you have to go to data definition language. So here are some examples. That creating, you can create objects in the database. Alter, you can alter the structure of the database. You can drop, you can delete the objects from the database. You can truncate, remove all records from a table, including all spaces allocated for the records are removed. Then comment, you can add the comment to the data dictionary. You can rename an object. So these are some of the examples of your DDL, say, commands. Then you have other language which is very important. We call it as data manipulation language. This data manipulation language, or in short DML, these statements, these are used for managing data within schema objects. So some examples are: you can select, retrieve data from a database, then you can insert data into a table, you can update that existing data within a table, you can delete the records from a table, and merge. You can you can merge two things. Then call, you can call a PLSQL or a Java subprogram from your TML, and you can explain plan, means explain access path to data, and you can also control the concurrency using your log table. These are again some of the commands which are there in data manipulation language. So this is a distributed transaction of a step ahead of database management system, which I wanted to highlight. You have a nested transaction or a distributed transaction. This is a nested transaction. This is a distributed transaction. Nested means you have transaction. For example, you have an airline database or a hotel database, and two different databases are there. And while in this distributed transaction, again you have sub-transactions, but you have a distributed database, means two physically separated parts of the same database. So same database, you can say it one here, one there. This is a distributed transaction, while a nested transaction is like this. Then there are few important things which a database should have or should contain, that is transaction management. A transaction is a collection of operations that performs a single logical function in a database application. So transaction management component ensures that the database remains in a consistent state, correct state, despite system failures, power failures, operating system crashes, and transaction failures. So either the transaction has to complete in entirety, or it should not, either 1 or 0, in digital if we talk. So concurrently, control manager controls the interaction among concurrent transactions to ensure the consistency of the database. Then one more important aspect of database management system is storage management. A storage manager is a program module that provides the interface between the lower level data stored in the database and the application programs and the queries submitted to the system. So a storage manager is responsible for what? Interaction with the file manager and efficient storing, retrieving, and updating of the data. So this is the overall system structure of DBMS. I talked about most of them today. These are the users. Say you are a naive user, or say you are an application programmer, you are a very sophisticated user, or rather you are a DBA, or a DBA means database administrator. These are all the types of users. So you for a naive user, you have application interface. For application programmers, there are application program. For a sophisticated user, of course, he has to give a query and get the result. And database administrator, let us have a database scheme. So these are the application program: object code, embedded DML compiler, DDL interpreter, query evaluation engine. You have known what the DML and DDL stands for. Then, which I just talked about, this transaction management and the storage manager. All these are there. This is the storage manager. These are the query processor. This is a query processor part. This is a storage manager part. This is the user part. And on the disk, you have indexes, data files, statistical data, and data dictionary. This is the overall system structure of any database management system. What are the advantages of DBMS? Controlling redundancy, sharing of data, data inconsistency, integration of data, integrity constraint, data security, report writers, control over the concurrency, like this, and backup and recovery procedures, and data independence. These all are the advantages of DBMS. Do we see any disadvantages? Well, the cost of hardware and software, because after all you have to buy a software and it will run on some hardware. Then cost of data conversion. If you have different database, you need to convert from SQL, PLSQL to say Oracle, or maybe I may have some two. You can just see two different database or database schemes or database languages you want to convert it. That will be cost bearing effort. And the cost of staff training, because DBMS requires a certain kind of skill. You have to have appointing technical staff, and if some database damage occurs, it will be very difficult for the organization to bounce back. So hopefully you got the idea what the database management system is. Thank you so much. Take care.